Oh, hey, how's it going? Welcome to the Land Ranger. So, for those of you that follow my channel, you guys know that I like a lot of service provider stuff. I've done DOCSIS, LTE, some other things under the hood, like CBRS, private LTE, and so on and so forth. But I actually got something that I've always been interested in doing, mostly because my home is actually serviced by something like this, and it's probably the sweetest thing in my arsenal, even cooler than DOCSIS because it's more modern, it's advanced, and it's also very capable of doing some neat things. So, this is a GPON. GPON stands for Gigabit Passive Optical Network. And what makes this so interesting is that this single SFP module can serve 32 houses. Stick around, and welcome to the Land Ranger. GPON, or Gigabit Passive Optical Network, uses a point-to-multipoint fiber design. So basically it's like you have a single OLT, which is the GPON that I showed you, just an SFP module, and that stands for Optical Line Terminal. But you have a single device, right? And then at the provider's like central office, it basically just transmits downstream data over a shared fiber to multiple ONUs or ONTs. That's optical network units or optical network terminals at like a customer's home. So like the simple way to understand how this works is basically it's downstream traffic is broadcast to every ONU. My house receives traffic from my neighbor's house and so on and so forth. But each ONT or ONU actually filters out its own encrypted frames. These are GEM frames. We're not going to get into that, but it's based on time division multiplex. So it's like TDMA, right? So each ONU basically transmits in assigned time slots. It's all encapsulated, which is what I was discussing earlier with Jim, which I think stands for GPON encapsulation method, but this carries Ethernet frames. So it's basically just Ethernet, except with light. So unfortunately, this device did not come with any instructions. As a matter of fact, this is the box I got. And inside of it was this device and this device. So I have played around a little bit with this. I didn't do a whole lot because I really wanted to do a video of us doing it together, but I did want to see kind of how this worked. And there is something unfortunate. So this actually does work in my Juniper EX4300. It also works in my FortiSwitch, just straight plugging it into the SFP port. The problem is that you cannot make configuration changes unless this is involved. So this does something. It looks like a media converter. It behaves like a media converter because SFP, Ethernet, RJ45. But let me plug this in here. Management only works when you use this. So it will serve customers without having the media converter, but unfortunately you can't actually make any changes to it. So I can't like turn off an ONU or OLT, but I can, pass traffic. I just can't see the end clients or manage any of the OLTs, which is actually what I got here, or ONUs, but this is an ADATA ONU, and it's tiny. Like, trying to think of something I could compare it to. Oh, well, the media converter. I mean, look how small that is. But yeah, so if you don't use the media converter, you can't manage these. You can't turn them off or on. They're just perpetually working. So with using the media converter, we could actually use the software. Now, the seller that I bought this from did provide me with a very sketchy software. So we're going to run it in a VM because it is a little strange. Now, like I said, I have played with this a little bit, but one thing that I didn't do that I am interested in doing during this video is I would like to plop open Wireshark so that we can actually see what exactly this thing is using to communicate with the management network. So let's get started. Alrighty, well, let's get into it. So you should be seeing my screen now. This is Wireshark, and you're just going to see random layer 2 and some ICMP because it's in my lab VLAN. You'll probably see STP and LLDP. Got some PIM going on, but I do have the software up. I'm not sure why it says online. That's strange. I did have this tested a few days ago just to see if I could get it to come online. I didn't have any devices plugged into it, so weird, but it was created with PyInstaller. So it's actually all Python based, and I will be doing a video on decompiling that and looking at its inner workings because I love looking at inner workings of things. But yeah, so this is it. This is the software, and like I said, I haven't actually made it this far with this, so I don't know what the traffic is going to look like, but we do have it in our lab VLAN Ethernet 2, just a secondary virtual NIC on the VM. So I'm going to click start real quick. Okay. There was a lot of traffic there. Let's try that again. It looks like this is our, keep my Mac awake here. It looks like this is our traffic. So destination, yeah. And you'll see GRE, this is encapsulated in GRE, but it's normal behavior because I'm using a remote port sniffer. But let's look at the data here. B95. That's interesting. Okay. Got some padding here. The length is 66 on that one. 50 here, 66 here. That's interesting. I wonder, well, it looks just like padding. Let's go ahead and power on our ONU. Gonna plug it in. And okay, it's showing offline now. That's great. Let's go ahead and click to start. I just want to see if we can discover the ONU and actually get real-time data and what that looks like. Still showing offline. The fiber is plugged in. Give it a second, maybe? Maybe the ONU is still booting. Yeah, one of the LEDs just popped off. Oh, OMCI. Look at that. It's in its boot process. Just like that, it's online. Oh my gosh. Okie dokie. Show FDB port 1. 3 MAC addresses. That's, oh, D05F. That is, actually, I'd like to see what that is. That's interesting. This is actually the ONU. It's already got an IP. It's reaching out to some sketchy places. Boy, oh boy. Why am I seeing 192 traffic? Is that the end client's IP address? Hold your horses, hold your horses. That is the end client's IP address. Let's see if we can log in to the ONU. Because I got my Mac plugged directly into it. Yep, we sure can. but we can't ping the internet. Oh, it looks like we're not natting. That's interesting. And before anyone asks, I stole this IP address. 40, 41, 44, like it is a public, but it's not owned by me. So we'll switch over to the MacBook here and log in as an ISP user and look at our WAN config. Oh, it does not have, it does have a route. Yep. All routes. I did not configure this, by the way. This was all DHCP. That network has DHCP. NAT type, full cone NAT, that's fine. But it doesn't look like it's actually natting. We don't appear to be natting. Service type. Okay, so we can make some, oh wait, NAT was disabled. We have to enable NAT. That might fix our problem. Oh my gosh. Do we need to reboot it? Oh boy. It thinks we have a /28. Okay. Can we ping 192.168.101.1? Yep. Can we ping? Can't ping anything else. Are we still natting? No! We have internet. So now we should look at traffic to quad 8. Or well, 8.8.4.4. And here's before we natted. So now we should be seeing traffic from 4.4.4, or not 4.4, but 40, 41, 444. So yeah, this behaves as a NAT device. This is fantastic. This is amazing. You can see the light levels. Really? Does this mirror add that much? This coupler must add an insane amount of attenuation. 17 dBm? Just kidding. Trying to make the photons go a little faster. That's amazing. We have internet. Oh my gosh. So I want to look at the FDB table again. It's strange that we are learning. I'm going to bounce that port. Disable port 1. Enable port 1. Show FDB port 1. Because we should not be learning the MAC address of the USB NIC on the ONU. Yeah, there we go. We're not learning it. Or USB NIC of the MacBook on the port. We should just be learning the ONU and then the OLT. Also, by the way, pure correction here, but I actually thought this was A data, but it's actually a CData ONU. So let's do some speed tests. I just got to see these speeds. 900. Oh my gosh. That's amazing. The upload is horrible. Comparatively speaking, why is the upload so bad? That's not good. So are we actually putting this thing under a load? during a speed test? No, we're not. This is amazing. So right now, the way this is working is, and if I had another ONU, which I probably will get one, this is actually just connected up to the OLT. So I could actually plug another ONU on this side, and then two will be able to operate, which I plan to do because these are $20. You could literally build an ISP. That's amazing. So I kind of want to log into the admin ISP. Let's see what options you get. Now, I built this earlier just for testing, but you could actually place the end clients in any VLAN that you want. And in my case, I reused the cable modem VLAN that I built for our DOCSIS video, which is 789. It was IPOE, or you could even do PPOE and then bridge. I didn't want to bridge. I actually couldn't get that to work like I expected it to. Let's see. Let's look at our PON config here. We see our PON MAC, which we see on our FDB table. Delta 0, 5 franc, alpha franc. Got our PON serial number, which we should be able to see in our OLT tool. We sure do. This is awesome. This is so cool. Vendor. So yeah, all we needed was the NAT option enabled. Otherwise, it would just try to route, which makes sense. It does have Telnet, but I don't, for some reason, I can't actually log into it with any of the credentials that I have existing. Remote management. Oh my gosh. That is so cool. So we'll have to revisit this. I don't want to do that in this video. Wow, this is so cool. It has some sort of loop detection. Ether type, detect packet interval, port configuration, forward, disable. So I guess if it detects, it probably sends a frame that if it detects this frame with the same ether type, it would probably just shut the port down. Loop status not exist. That's really cool. So you wouldn't take the whole PON network completely offline. So, yeah, I think that's it for this video. I just wanted to get that labbed up. And man, this is so cool. Like, that's awesome. Let's do another speed test. I think what I want to do is combine all of the things, service provider things that we've done. I want to feed our CMTS over a PON network. And from the CMTS, I want to connect our private LTE gear and then have like a full chain of spaghetti. That sounds amazing, actually. I think I'm going to do that. I think that's a good idea. But yeah, this is awesome. So this is the GUI, and you could actually change some of the PON information, user password, successful registration 05. So there's actually different PON statuses. PON serial number, it converts it to hex for you. That's pretty cool. H1 mode, H2 mode. This thing has, so it's interesting. So if you were an end user, you would just log in with the default admin, and then this is all you would see. You can't see anything else. I'm not really sure. Firewall, high, low, doesn't really do anything, I'm sure. NAT type, full cone NAT, port restriction or restricted cone. It does have DMZ, and it looks like we could actually port forward things. That is so cool. Let's see, is this accurate? Is the... Oh, wow, that is so cool. 900, yep, 900 down. So yeah, that is accurate. So um, yeah, but as an end user, when you log in, you see your light, but you don't see anything else. But there's actually an ISP account that you can log into, and then you get the rest of this stuff where you can do things. So yeah, GPON in lab. Hope you guys enjoyed. Thanks for sticking around.